Hey, this is Mr. C, and we're grooving right into another math lesson. Once you're done writing your name and the date and the title, let's get going. Alright, now check your homework. 3, 2, 1, go. Let's learn about the greatest common factor. Alright, let's zoom in. That was a good time. Okay, so when we're learning about the greatest common factor, first let's ask ourselves this question. How can you find the greatest common factor of a set of numbers? So GCF stands for greatest common factor. In other words, I call it the biggest factor in common, if that makes more sense to you. We learned what factors were in the last lesson. So now we're going to look at two numbers, and we want to know what's the biggest factor in common between both of them. Let's read this word problem. Keisha is putting together bags of supplies. She has 42 craft sticks and 12 glue bottles. If she puts an equal number of craft sticks and an equal number of glue bottles in each bag, how many bags are there? Oh, we don't know how many bags there are yet. What is the greatest number of bags Keisha can make so that nothing is left over? So we're trying to find how many bags there are going to be. And we want an equal number in all of them. All right. So we have 42 craft sticks and 12 glue bottles. How can we split those up equally? Let's move on. So first, we're going to list and compare all the factors of each number in the set. All right. So for the factors of 12, it's 1, 2, 3, 4, 6, and 12. All right, well, how did I get those numbers? Well, I'm going to start at 1. I know that 1 times 12 is 12. Let's go to the next number up from 1. That's 2. 2 times 6 is 12. Let's see if 3 works. Yep, 3 times 4 is 12. And there's no more space here for any more numbers. We've already exhausted all of our options. Now let's look at 42. Well, we would do the same thing. Let me make this list longer to make it easier. All right, I just moved these numbers up here. All right, so 1 times 42 is 42. Then you ask yourself, 2 times what is 42? 2 times 21, and so on. This is how we got these factors. But now we're looking at these, and we're thinking, what is the biggest one in common between both of these? Well, I see a 6 here, and I also see a 6 here. There's no number bigger than 6 that's a factor of both. There's 12 here, but this one doesn't have 12, and we want them to be in common, which means both of them have it. So 6, in this instance, would be called our greatest common factor. But specifically, 1, 2, 3, and 6 are common factors. So greatest common factor is our vocab word for today, and the vocab notes will be right after this. But the greatest common factor is the greatest number that is a factor of 2 or more numbers. So 6 is the greatest common factor of 12 and 42. So answering our question before, which was what is the greatest number of bags so none are left over, well, Keisha can make 6 bags. So there would be 2 glue bottles and 42 sticks. Let's move on. With a clue word of red pointer. To hear your vocab notes, make sure that you underline the word and write the definition underneath. Moving on in 3, 2. All right, and I kind of want to do this example with you. Just act like this is Mr. C, and this is my wife, Danny, and we both like kind of restaurants. And so I like McDonald's and Burger King, and she likes Taco Bell and Runza. I'm putting this in comparison of greatest common factor. I see down here there's yogurt, and I don't see yogurt over here, so that's not a common factor. I see hamburgers and hamburgers. That is a common factor. And so I'm going to write that we have in common hamburgers. Sometimes students might write, if this was actually a number like 7 and 7's over here, they might write, for the common factor, they might write 7 twice. But in this case, it doesn't make sense because if you both like hamburgers, you wouldn't say, in common, we have hamburgers, hamburgers. You wouldn't write it twice. So don't write the number twice when you have it in common. Just write it once. So I'm looking again, and I see that we both like fries. So I'm gonna write that we both like hamburger and fries, not that we like hamburgers and we like fries and fries. That doesn't make sense. So you're gonna underline both and then just write it once. Underline both, just write it once. All right, so let's go into example 1. We learned about prime factorization before, and how can I use that to find our new term GCF, or greatest common factor, which I know you have some background information on. So let's find the greatest common factor of 60 and 80. So in your notes at this time, please write step 1. Find the prime factorization of each number. You don't need to write the tip, but we are going to make factor trees for these numbers, so let's get started. You should have 60 and 84. Just some review, I'm going to do 60 with you, and then 84 is going to pop up. But 60, already see it's even, it ends with a 0, so let's do 2. 2 times 30. I'm going to carry that 2 down. 30, all right. Oh, I see that I can 3 times 10. I saw that it ends with 0. All right, so I know that's another prime number. I'm going to bring that down, and something times something is 10. That's 2 times 5. All right, so now I have 60, and as you see right over here, they have 60 is 2 times 2 times 3 times 5. And I would get that, except I copied something wrong right here, so let's bring that to a 2. And I have the same exact thing, except they move the 2's next to each other, followed by the 3 and then the 5. Now I'm going to fast forward and show you 84. As you see the tree right here for 84, 2 times 2 times 3 times 7, which is exactly what we have over here. They combined the like numbers. Instead of 2 times 2, they have 2 to the second power, and the same as here. And we want to know what's the greatest common factor between these. So now we're going to talk about how to do that. If you don't have this written as well as this, please do that now, because I'm about to move on in 3, 2, 1. So I'm going to look what they have in common between the prime factors. So this is what it is right here. Those are their prime factors. And in common, I'm going to circle the ones they have in common. They both have a 2, and they both have this 2. They both have this 2, and they both have another 2. They both have a 3, and they both have 3. But they do not both have a 5 or a 7, so I can't circle those. So now I'm going to take the common factors, 2 times 2 times 3. That's what they have in common. And when I multiply those, I see right over here, I'm going to get 12. 12 is the greatest common factor of 60 and 80. Make sure you have this written as well, following with step 2 to keep our notes organized. We're moving on in 3, 2, 1. So let's talk about example 2. Do the first 2 problems first. If you find it difficult to do it by yourself, you can watch me do it first and then write it down, but try to do it by yourself if you can, and then we're going to come back and do 2 more problems for example 2. Try these on your own, and the answers are coming in 3, 2, 1. Alright, so for this one, I made a factor tree for 18 and 36. I'm going to underline the specific ones they have in common. They have this, and they have this. I underline them. I want to make sure that I counted it, so I'm going to write 2 down here. Alright, I see there's a 3, and there's a 3 times 3. And then I see another 3 and another 3 times 3. And I'm thinking in my head, can I put another 2? Well, there's a 2 here, but there's not another 2 here, so that's not in common, so it's going to stay right here. So now I'm asking myself, what is 2 times 3? Well, that's 6. 6 times 3. Their greatest common factor is 18. And yes, that is possible. It could be as big as the number itself. Let's go to number 2. Alright, so as you look at this one, you might see that this is a little bit easier. There's only 2 factors for each. Only 2 possible factors for each of these, because both of these are prime. And now I'm underlining the ones they have in common. I see they don't both have a 2, but they both have a 7. So I'm writing down my 7. And I can't underline anything else. So my greatest common factor is just 7. And it's that easy. If you don't have this written, make sure you write it right now. And we're going on to the next ones in 3, 2, 1. So we're on numbers 3 and 4 for example 2. Please try these on your own. And the answers are coming in 3, 2, 1. Alright, so I'm specifically looking for the greatest common factor from these 2. I see a 2, there is no 2 over here. I see an 11, there's an 11 here. I'm going to write down my 11. That's the only thing in common, therefore the greatest common factor of 22 and 55 is 11. Over here at 25 and 100, I see a 5. Do I see another 5? Well, first of all, this is kind of confusing because I need to bring my tree down. Alright, that's better. Now all my numbers are in a row down here. Okay, I see a 5 right here and a 5 right here on both sides. They share that. It's in common. So I'm going to put a 5 down here. I see another 5. I'm looking for another 5 on the right side. I see another one. I'm going to underline both and add my other 5. See, I see 2's down here, but there are not 2's over here. So 5 times 5 is their greatest common factor, which is 25. All right, moving on. Here's your independent or partners practice. Please pick 3 of these, and when you're ready for the answers, we're going to show you in 3, 2, 1. Here are your answers for 11 through 18 independent or partners practice. After you're done checking that, please choose number 1, 2, or 3 as your option after the lesson. And we're coming with the answers to the group game in 3, 2, 1. Here are the answers to the group game. And don't forget, you are awesome. Thanks for watching this video. I hope you learned a lot.